before running in the algorithm, TF-ID, the algorithm. So next, after what I am doing, okay, so once let us imagine after the training, after providing the training value, so I want to predict. Okay, so to predict what I'm doing, I'm going to have the variable called y of predict, and in y of predict, I'm going to pass my test value. Okay, so to test the algorithm here. Next, simply I'm just try to display some values like classification report. Classification report is equal to y of test line, y of the predict. Okay, based upon this, okay, y of test as well as the y of predict. Okay, so I'm going to generate my classification, the report with respect to the TF-ID algorithm. So let's try to run this. Okay, it got executed. Now next is obviously we need this package called linear SVC. Okay, so let's try to import this package called linear SVC. Okay, it got executed. Now next is I'm calling this linear SVC subclass, which is in sklearn of SVM in CLF. Okay, so now next what I'm doing, I'm just passing these parameters. This I'm just going to run this function, run SVM with respect to these parameters. Okay, let's see how much we are going to get. So run this one. Can you see this? Hello, hello, hello,
Yes, sir.
Yes,
Yes,
sir.
sir.
hello.
Yes, sir.
Hello, sir. Yes, sir.
Yeah. How much accuracy we are getting here? Yeah, how much accuracy we are getting?
Point
Can you
eight.
see this one?
Yes, sir. 81.
Yeah,
Okay.
0.81. 81% of the accuracy we are getting after the word to vector. Okay, if you compare this one with the normal TF-ID the algorithm, so there is a difference of 1%, right? Yes or
Yes,
no?
sir. Yes, sir.
Hello? If there is a
Yes, sir.
difference of 1%, that means there is, okay, the improvement. I can see some kind of an improvement in the algorithm. Okay, so using TF-ID algorithm. Similarly, so I can choose this model also. 81% accuracy it gives. Let's try to boost this algorithm. Okay, let's see how much we are going to get here using CNN algorithm as well as the birth algorithm. Okay, so next, let's try to run now. Uh, let's try to run both the algorithm, that is CNN as well as the birth algorithm. Okay, so first we need to prepare the data to run for CNN as well as the birth algorithm. So to run that one, we need this package. Okay, core web log, word to vector count. Okay, so generally what happens, suppose you take the categorical data, that also those the statements are there, which is in text, that is also one form of categorical data. But if you are using one hot encoding, okay, so one hot encoding is limited. So yeah, there are certain limited options are available in one hot encoding a system. So if let us imagine that you have very lengthy text and you want to process that very lengthy text, okay, so we can use this the package. It is also possible with one hot encoding, but this works fine compared in sentiment analysis. Okay, so let me run this one. Run spaCy for the encoding purpose. We are using this library. Hold on, this takes little time. Okay, so already almost all the coding I have written in the background. I'm just trying to run and explain. Okay, so the code here. But still it takes a time because these the libraries and the time which is taking to process this algorithm takes a lot of time. Hold on. It is almost around 800 MB of the file. 827 MB. Okay, so it started executing. It's collecting all the packages. Okay, like these are the packages which are offered in this particular package. These are the features which are available in this package. Let this get finished first. So till then, what I will do, this takes bit time, little time. So till then, let me try to explain the CNN. Okay, how exactly the convolution neural network will work. Hope you can see my screen now. Okay, so this is the PPT. This is a simple example what I have taken to explain the convolution neural network. Hope you can see the screen. Suppose imagine that. Hello, can you give the confirmation, please? Whether you are able to see the
Yes,
screen
sir.
or not?
Yes, sir.
Okay,
Yes, sir.
so
Fine.
this is now next to what I'm going to do. I'm going to run my convolution neural network. Okay, to find out the accuracy. So just to understand how exactly the convolution neural network works, I've taken one simple example. Let us imagine that I want to recognize this word called to. Okay, to. So to recognize this, the word called to, I'll use this. I'll try to process the data in different the stages. Generally, what I have done here is, okay, so I have taken word pixel image. The image I have taken, which is of the size 28 into 28 into 1. Okay, so 28 into 28 is nothing but the height and width of the image. Next, 1 is nothing but the depth of the image. Okay, so in before passing this the data toward using the convolution neural network, so you need to process. You have to process this data in stage vices. Generally, what we do, suppose let us say 28 into 28 pixel value we have. Okay, so in next in the hidden layers, so the entire convolution neural network divided in three parts. Okay, so first is called input layer. Next we have hidden layer. Next we have the output layer. Okay, in convolution neural network, what happens? Okay, we can set the output here. Suppose let us say I want to have 90% of accuracy. We can set. Okay, so we can process that the entire data in the background until we reach 90% of the accuracy. Okay, hope you are clear with this. So here what I am doing, the pixel, whatever the image is there of 28 into 28 and depth 1. So I'm going to divide this, okay, the entire the data or the image into 24 into 24 pixel image. Hope you are clear. Hello, hello. Okay, so
Sir.
what I'm going to do here is 28 into 28 is there. No, I'm
Yes,
going to
sir.
take the slices of,
Hello.
yeah, I'm going to take the slices of those images, and I'm going to convert this one in terms of 24 into 24. So that means the pixel again it is decreasing here. Now next is, so we can have the batches over here of the single image.
Sir.
Yeah,
Sir.
yeah.
Any reason, sir, why we should take 24 into 24?
Because okay, 24 into the, because before passing this one to the neural network, okay, so that means the pixel should be reduced here. Okay, so pixel should be reduced. Okay,
Yes,
so
sir.
we need to generally what we do, we try to convert the color image or any images into grayscale. Fine.
Yes, sir.
Okay, so here what I am doing, so I'm just reducing it. Let's say you have 256 into 256. Okay, the pixel images. Okay, so we cannot process that data. It is possible to process the data, but it takes a lot of time in the hidden network while processing the data. Understood? So that's the reason what we do. We try to reduce the pixel images. Okay, as much as possible. Next, okay, here we can have the batches. There are certain restrictions to have the batches. You can have the batches of 32, 32, 64, 128, 256. But while selecting the batches, make sure that okay, so you should have the the computations, more computation power. Okay, so if you have 60, if you are creating 64 batches, make sure that your computer are having that much of capacity to process 64 the batches of the images. So here what I am doing, I'm going to have only 32 batches. Okay, 32 batches of this image of 24 into 24 the pixel image, and depth I'll try to keep as 1 only. Okay, if you are creating 32 batches, it is going to be 24 into 24 into 32. Okay, and to perform this, to reduce this the picture image from 28 into 28 to 24 into 24, I'm using the concept of padding. Okay, this process is called padding in convolution neural network. Hope you are clear. Hello. Hello.
Yes, sir.
Okay, so
Yes, sir.
I'm going to have the concept of the padding here.
Yes, sir. Yes, sir.
Okay, so next is
Yes, sir.
uh, 32 batches of the images right now have. That means 32 images of that character called 2 is going to have here. Understood. Now next is what I'm going in the next stage. I'm going to perform max pulling. In max pulling, what happened? Let us say you take the corner image, corner part of the image. Okay. Hello. Hello.
Yes, sir. Yes,
Okay,
sir.
so in generally what happened, you try to take the corner part of the image. Okay, so
Yes, sir. Yes, sir.
in individual pixel will have certain kind of in weight. Okay, suppose let us say, how I can demonstrate that. One second. How I can demonstrate that. Okay, so let us imagine. One second. Let me try to explain that one. Max, max pulling. Max pulling. Hold on, max pulling. Max pulling. Max pulling. Hold on. You can try to have the image. Okay, have a look. Can you see this diagram, participants? Hello, hello.
Yes, sir. Yes, sir.
Have a look.
Yes,
Yeah,
sir.
Yes, sir.
Yes, sir.
have a look on this. In max pulling, generally what we do, either we take the maximum value, okay, or we try to take the average of the surrounding pixels. Suppose let us say this is 2 into 2, 24 into 24 pixel image. So I'll try every pixel in that image will have the weight. So what I will do, okay, so I'll try to divide in this in terms of matrix format. Let's try to have the 4 pixel here. Okay, right now what I'm going, okay, I'm going to have the 4 pixel. 12, let's say 12, 28 and 12. Okay, so in max pulling, so whichever is having the highest weight, let's say out of 12, 28 to 20, which is having the highest weight here?
20.
Can someone tell me? 20. So the 20 will be
20, sir.
considered in the next level. Okay, 20 will be considered in the next level. That means instead of choosing the entire weights of the images, I'll choose only the 20 here. Okay, in the next level. Yes, in the similarly, let's try to take
Okay.
this matrix now. 30, 0, 2, 0. So which is having the highest one? 30 is having. So I'll
30.
consider 30. 30.
Yes.
Similarly here also. And here also. Understood? So 1, 1,
1, 1.
12 and 37. Yeah. This will be considered, this image will be considered in the next level. This is one option. Okay, so generally we use. And the another technique generally we use, okay, in the max pulling is by taking the average of all these weights. Let's say 12 plus 20 plus 8 plus 12. Divide by how much? 12 plus 20 plus 8 plus 12. Okay, divide by 4. Whatever the value we get, we are going to consider that value in the next level. Okay, in the same way in the other things also. But if you are taking average, again you need the computation power. Okay, to calculate the average value of those pixels. Okay, that concept is called, hope you are clear with the max pulling system. So that is
Yes, sir.
called the max pulling system. Okay, so same thing I'm going to perform in the next level. So have a look on this. Okay, 24 into 24 I've done. While padding, after padding, I'm performing max pulling in both. Okay, so both will be performed together here. Okay, padding first I'll try to have padding, next I'll try to have max pulling. So it has reduced, no, the pixel value has reduced from 28 to 24 now. In the same way, I'll perform the padding and max pulling in the next level. Have a look on this. Can you see the difference between this?
Yes, sir.
Uh, okay, so right now here we have the pixel image of 24 into 24. So I'm going to have what, 12 into 12 by using performing, okay, the max pulling technique. But 32 batch is there. Okay, so drastically I'm reducing 50% of the pixel image right here.
Yes, sir.
Hello. Okay, so that means
Yes,
I'm
sir.
going to drop. I'm going to drop 50% of the layer, okay, or 50% of the batch file size, okay, in the next layer here. In the same way, okay, so I'm going to consider only 32 batches in the next layer. Same way, okay, in the third hidden layer also, I'm going to perform the same thing, max pulling and padding or max pulling. So again, I'm going to reduce, okay, around 25% of the layer here. Okay, I'm going to consider only 32 batches in the next layer, and it continues until I reach, okay, 4 into 4 matrix. Hope you are clear.
Yes, sir.
Okay, so next,
Yes, sir.
whatever the data we have here, 32 batch data we have, right? That will be given as an input, okay, to our convolution neural network for its processing. Hope you are clear.
Yes,
Okay,
sir.
and generally what we do, we try to use the unit as sigmoid unit. We use sigmoid unit and ReLU function. Okay, so or sometimes we use softmax function also. Okay, so in this case, what I'm going to do, I'm going to consider it as a my unit as ReLU function. In ReLU function, what happened? So we can set the range. Suppose let us say you are setting the range as 0 to 1. Understood. Now what I will do in ReLU function, I'll try to give 0.01 for the first processing. So that means to reach 0.0 to 1, so it will be processing like 0.1. In the next process, it will add one more 0.01. So that means, okay, in the second execution, it is going to set as 0.02. Like that, it keeps on processing. It keeps on, okay, executing your data until it reaches 1. Okay, which is nothing but the targeted output also, I can say. Okay, target, let's say if you are setting as a 90%, I want to reach as a 90% accuracy. So that means, okay, it keeps on executing until you reach the, okay, 90% of the accuracy. In the same way, we can have the verbose also. Verbose in the sense, let us imagine that you have completed one cycle, forward pass and backward pass. Okay, so we can have another cycle, let's say verbose. Okay, so second cycle, second time you are executing, we can have n number of verbose, but while choosing the verbose, make sure that okay, it should not take the lot of time. Okay, if it, even if it is taking a lot of time, well and good, you are going to get the better accuracy, but it is a time consuming the process. Hope you are clear. In the same way, what I'm going to do here is I'm going to process in the same way of my in the sentiment analysis. I'm just replacing this two word with my the words. Hope you are clear.
Yes, sir.
Hello. Okay. So two word I'm just trying to replace with my number of the words there. Okay. So
So,
let's start then. Yeah.
sir, depending upon the pixel size, what we get at the last. So, based on that, we have
Okay.
to
So
allocate the numbers. Some coding we have to allocate.
exactly.
Okay, that's why we are decreasing the
Okay.
pixel size.
Yeah. Pixel size we are decreasing here.
Okay.
Okay. Okay, so next is, in the end, always remember, we need the data before passing the data in the input terminal. So make sure that we will be having the data in matrix format, less matrix format, 4 into 4 matrix format,
Okay.
2 into 2 matrix format. Okay, because it's processing for the process, it will be easy in the neural network. Doesn't matter whether it is an image or you take the text data or any category of the data, try to convert it into the matrix format before passing it to the conversion neural network. Let's dive into the code now.
Sir, here,
Hope you can.
is there any rule, sir, that 28 has to be divided to 24 and then 12 like that, or can we
No.
choose the random numbers like that?
Yeah, we can do it. Okay, so we can choose the random number. Okay, so 24 from 24 I have reduced 50% of the layer.
Ah, yes, sir. So
Okay,
from 28,
but yeah,
from 28, can we jump to 12 like that, or will there be any effect on the
it's
output?
yeah, it's possible. It's possible. Directly you reduce the 50% of the layer.
Okay.
Okay, 24 to 12. Next 12 to 6. Understood. If
Okay.
you're taking 6, so always here, if you're taking 6, okay, so here we need the matrix in the format 4 into 4. Have a look on this. If you're reducing it to 2, okay, so next in the next stage, I need the matrix in 4 into 4 format. It's possible. Okay, but make sure that from 6 you have to convert into 4 into 4 matrix.
Yes, sir.
Okay.
Yes, sir.
Okay, so here have a look on this. Here I have you can see that difference here. 24 into 12. That means 50% of the reduction in the layer. Next year I have just 25% I'm giving, okay, in the reduction of the layer. From 8, again the 50% of the reduction of the layer, dropping of the layer. Okay, so that means 4 into 4 I have. So this I can give it to my the neural network here. Okay, so it's up to you. You take 256, but make sure that okay, while before passing the data to the convolution neural network, okay, try to keep the data in form of 4 into 4 matrix. Hope you are clear. So that means 4 into 4 matrix means I'm going to have 4 terminals. 4 terminal input, 4 input terminals. For from 4 input terminals, I'm going to pass the data. Okay, for its processing. Okay, so this is we need to perform this one before passing the data into the convolution neural network. Okay, so this is pre-processing is required in convolution neural network. I'll show you that one how I have done using the TensorFlow system here. Okay, TensorFlow Keras system. So sorry, TensorFlow system. Okay, so I hope you can see my coding screen. So my package is already downloaded. I have downloaded and I have installed my package. So next I'll try to import this package. Okay, so I'll try to import this package. It says Spassy. I want the Spassy. Ah, I want the Spassy and okay, this core web log. Let me run this one. Let me run this one. Yeah, it got executed. Next, I'll try to store whatever the options are offered by this package. I'll try to store in NLP variable. Let's try to run this one. Okay, let's try to run this. This take little time, okay, because it's very large file. NLP dot the load that package. Yeah, it got executed. Now next is uh, next. Okay, so I'm going to define one function here called get value, and my x is having which value here? Can someone tell me? X is having my text data, right?
Yes, sir.
X is having my text data. Yeah. X is having my text data here. Okay. Yeah. X is having my text data. So hold on. Okay. So sorry, I'm creating one parameter here called X. Okay. That is my data is in capital letter X. Okay. So I'm creating one data the variable. Sorry, the function called get value. Run this one. Okay, and I'm loading this the parameter x my to NLP. NLP is having my that value. Next is okay vector. I'm going to create one more vector variable. Okay, and the whatever the data which have converted in terms of vector format using word to the word to vector concept. Okay, so that I'm going to store here, and I'm going to return my the vector value. Okay, so you can check this one if you want. You can check. Quit will be having one more feature called the vector. Okay, so next is okay. So twit vector. I'm going to extract the data, which is the new feature which is in the twit data. Okay, and I'm going to join that one. Okay, in my the real data set here using this function called get value function. So run this one. Run this one. Hold on. Lambda function okay, will take time because I'm going to join all the values here. This takes time, participants. Around 1 minute it takes. Hold on. Okay, it got executed. Next, let's try to see the status. Okay, so how we are representing it in quit. Okay, can you see this? Have a look. Here, have a look on this. Okay, the data looks like this. Okay, data looks like this. There are 6 columns here. So after vector represented, this is the vector representation of my the data, target data. Okay, and these values are there. No, these are values are the weights. Okay, so the weights of the individual, the entity or the sentences, so not sentences, individual words I can say. Understood? So generally in word to vector, what we have done, we have converted that into, we have given the individual code for the entity or the word I can say. Understood? So in the vector representation, okay, that weight will get converted into the vector form here. Understood? So we have the new feature here. Okay, key ID keyword. There are 6 columns here under this, and record, there is no difference in the records. Records remains the same. Now, okay, so to process this one, okay, to process this one, so I have to convert this one in terms of numerical value. Let's say negative values are there. Okay, so I have to eliminate those negative values. To do that one, what I'm going to do, I'm going to use one more package called numpy. Numpy is very good to handle the numerical the values. Okay, so let me run this one. So says X is having my data. X is having my actual data. Okay, so I'm going to add this one using the twit vector data. This data I'm going to add here. So let's try to see that, and we are going to reshape the entire data set. That means we are going to have the extra one more vector over here. So let's try to run this. Run this one. It got executed, and let's try to see the shape of my X value. Can you see this? Hello. So what happens here is, okay, so the entire this data is there, right? Okay, so the entire data is stored in one matrix format. Okay, so it is maintaining only one matrix. Okay, so that is the reason the feature is showing like a only one. Okay, so we need to concatenate. Okay, so we need to take this one out of the single matrix. Okay, so to have this, what I will do, I'll try to use concatenate technique. Okay, and I'm going to assign this. I'm going to convert this entire one feature into 300 features. Let me try to run this. Run this one. X value. Okay, it got executed. Now you can see the shape. Run this x dot shape. Okay, so now one feature, one matrix. Okay, we have now from one matrix we have created the 300 features of my X data. Same way, okay, I'm doing this one for text data. Remember, X is having my text data. In the same way, let's try to have target data. Target is nothing but binary values, zeros and the one here. Okay, so run this one. Y, I'm going to assign the target value in Y. Now I have two separate data now. X and Y. X is nothing but the independent data, and Y is nothing but the dependent data. Understood? And X is having these many records. Yeah.
Sir, one thought. Sir, here we got 300, no, sir, 300 columns.
Yes.
X dot shape. Means how it is converted
Exactly.
to
Exactly.
any data is again copied there. How it is dividing, sir? We have only one column, no, sir.
So actually, have a look on this. What is happening here is, so this data is there, no, the complete record data. It is in the array format.
Yes, sir.
This is one array. Okay, this is one array. Okay, so this is another array. Okay, so this is another array, and this array I've stored using one single matrix.
Okay, only within one column.
Okay, within one column the complete array we have stored.
Yes, sir.
Understood?
Yes, sir.
So next, I have to take out that one from a single array. Sorry, single matrix to, I'm going to have the records here 300. Okay.
Yes, sir.
Hello?
So,
Okay.
yes, sir.
Yeah. Any further doubt?
Means how those columns will be there, sir?
Huh?
Can we just see the table now, sir? Of
Yeah,
table?
sorry. No, it's not columns. Actually, it is the records. Okay, the records which are there. Let me try. We'll see the records first. Hold on. Record is in tweet, no?
Yes, sir.
Tweet target. Okay, so let me tweet target. So this is the in why actually X is having. Have a look on this. So first, let me go here. I think I have divided the entire data set into X and Y. Have a look on this. X is having. One second.
Yes, sir.
So I have divided the complete data set in terms of X and Y.
Yes,
Now
sir.
my X is having the value.
Under
Sorry.
target column.
Yeah. X is having my not target. X is having my target. Sorry, text feature.
Okay, sir.
Weird.
Yes, sir.
Okay. X is having my the text feature. Let me run this one. It has not yet. It is not functioning. It should be just a hit. Anya, any doubt?
Sir, in that array, each word is storing in each array.
This one.
I didn't understand that array.
One second. One second. X is having X dot head. X dot should be bit dot. Let me check it. Bit dot head. Should not be X dot head. It should be bit dot head. One second. Bit dot head. Bit dot head. Okay, so let's try to run this one. Can you see this one? Target value. Hello. Hello.
Yes, sir. Yes, sir.
Okay. Target value. Have a look on this. My the twit is having one more feature called the vector here. Understood. So here what we have done, we have assigned our is there. Our okay, we have converted into this one code. Participants, hello. Swati ma'am.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay,
Yes, sir.
so we have converted in this code and we have stored the sentence right in the form of array.
Yes, sir.
Okay, in the same way, this you take forest. Forest is having this value. Okay, so this is the encoded value of forest. Okay, and we have stored in the array format. Okay,
Yes,
so
sir.
next is okay. So that we are going to convert this. Now we are going to take only the text data. Text data I'm going to store in X value.
Okay, sir.
Okay, so here. Okay, text data I'm going to store in one value. Here, since I have negative values here, okay, so that should be removed. Okay, so to remove, generally what we do, okay, vector form, vector, let's go to vector, yeah, vector feature. Okay, have a look on this. So negative values are there, so that should be removed in vector feature. That's the
Yes,
reason
sir.
what I'm doing. Okay, I'm going to use my the numpy technique here to handle the numerical values. Okay, hold on. Okay, numerical values. So reshape. That means this. What happens? This will be the entire data is it is going to store in one matrix format. Okay, so that's the reason it is showing like only one feature. So next, what we are doing? Okay, so we are going to convert this one in terms of 300 features. Okay, hello,
Yes, sir.
hello.
Yes,
Yes,
sir.
Okay,
sir.
we are going to convert in terms of 300 features. Let's try to check this one now. Actually, what I will do? Let's try to have one more column and insert one more new cell. not here. Insert here. Insert code set. Okay, let's try to check this data. X dot head. And this one. It's not showing. What is the problem here? Head of should be. It's not 300 features is showing. Shape. Shape I can see. Head of vector. So we have vector here. Vector and enter. It's not showing. MPY object has no attribute called head. Yeah, so it's not showing. Oh, anyways, hope you are clear. We are converting into 300 features here.
Yes, sir.
Hello?
Yes, sir.
Okay, so I'm reshaping it. This negative values are there. No? I'm reshaping that one. Okay, to positive values here. Next is same way. Let's try to take the another data, the feature that is called the Y, which is in the twit. Twit of. Let's try to have twit of here. Twit of. Hold on. Twit of Vic. Okay. Connect. NumPy is not separating that twit of. Anyways, so next you take the next data, that is Y. Okay, so hold on, let me see. Yeah, run this one. So Y is nothing but the target data. I'm going to concentrate on target data here. So target data is having 0s and 1. Now I have both X and Y value. Let's try to split this X and Y value in terms of training and testing. So for testing, I'm going to have 20%. So this is the same code I'm going to run here. Okay, so run this one. So the entire data set will get converted into training and the testing values. Next is I have one function called the run SVM. Okay, so already I have created. Let's try to see next to how much amount of accuracy it is going to give me. Can you see this one? 81 we are getting, right? Hello.
Yes,
Hello.
yes, sir. Yes, sir.
81 we are getting. Let's try it now. Next we'll try to use CNN algorithm now. Okay, CNN convolution neural network. Last time while explaining, okay, so the mistake was a typo mistake. Convolution 1D. I'm going to use convolution 1D here. Okay, one dimensional array. Max pooling 1D. Okay, global match pooling system 1D. That is for the sampling purposes. Okay, dense layer. Okay, dense layer are nothing but to work on the hidden layers. So suppose if you want to say you want to drop. Okay, so to drop the layer, let's say 50% of the layer I want to drop. So okay, so generally what we do, we try to use dense and flatten. For embedding, for the converts, okay, for converting the codes, okay, so we use embedding system, dropout layers. For the dropping purpose we are using token. So I'll create one variable called token. Let me run this one first. Okay, so after running, so I'm going to use Keras model here for pre-processing of my text value. Okay, so while pre-processing of text value, we should use this tokenizer technique. Okay, since all the data is in the vector format now. Okay, I'll use this method called tokenizer from this Keras pre-processing text. I'll try to store this one in token. Okay, token value. Let's try to run text. Let's try to see the status. Okay, the text, what text value is having, which type of a data is having holded by the text. Have a look on this. So I have this data in the text. Okay, so next is let's try to fit this one to the text data. Let's try to fit the text data using the tokenization, the concept. Okay, so let's say run this one. Okay, so now it got executed. Now the token, that means the text is fitting. That means it is suiting to my the algorithm now. Okay, vocabulary size. So we can check the vocabulary size. Okay, how much vocabulary, what number of words we are using here. But as far as Keras is concerned, to check the vocabulary size, this is a standard format. We need to add. Okay, so this is the normal statement generally we use to check the vocabulary length, the size, length of token dot word index. Word index is a method. But if you are using Keras, so you have to add plus one. Okay, so run this one. Vocabulary size. Okay, next to vocabulary, let's try to see the size of the vocabulary, our data. Vocabulary size. Can you see this one? Hello, hello.
Yes, sir.
Hello, sir.
22,007
Yes, sir.
22,701 words are available in this. Okay, so let's try to print this one. This is another method. Okay, so print this one. Okay, so have a look on this. Now what I am doing, T I'm going to assign. Okay, so now I have to convert it into the numerical value. For T I'm assigning 1. CO I'm assigning 2. HTTP I'm assigning 3. Like this, it is going to assign the numerical value for okay all the Earth words of 22,701. Can you see this?
Yes, sir.
Yes,
Hello.
sir.
Yes,
Yes,
sir.
sir.
Okay, so we have assigned the values here. Okay, for 22,701 vocabulary. Now next try to encode this one. So to encode, okay, I'm going to use the encode library. Where it is, yeah, this is embedding system. This is I'm going this the concept I'm going to use this to encode my the data or the vocabulary also. You can say. Okay, so encode this. Where it is, yeah, encode text. Encode text variable. Okay, so call this method to encode the text values. Now next is let's try to print this one. Let's see how it looks like. Have a look on this. Can you see this? We have encoded. Have a look on this.
Yes, sir.
11946. Yeah, so that means it's very difficult to understand. So all the coded. Okay, so the complete data is got converted into the coding values. Now this have a look on this. So this is one array. It is storing in terms of array. Okay. Same way, this is the another array of the next record. Okay. So next is let's try to check. Okay. Maximum length I have given 40. Why I have given 40? If you check the words count in visualization, in last time in visualization we have seen words count. Where is words count? Words count. Character counts we have seen. Okay. There is a word count. Even we have visualized word count also. Character count. Okay. Next is character count density. Next we this is the text data visualization. Hold on first. Here in word count, this is character count. So this is a word count. Can you see this? Okay, in word count. Okay, can you see this one? Maximum word count is how much here?
Yes,
35 is there, no?
35.
In between 30 to 35 we have, right?
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
in between 30 to 35 we have word count. So what I have done, okay, so I have set the maximum length for my word count as 40. Okay, so it should not just to avoid okay to crossing the limit 40 I have given, or else you can set as a 35 also. Okay. It's taking note. It's yeah. Yeah, here. Vocabulary size over. This is also express text. Yeah. Maximum size 40 I have given here. Okay. So run this one. Now just try to convert. Now I'm preparing now my X value. Okay, before passing this one to my convolution network. Okay, so by using the method called pad sequence, encode text is having my encoded value here. This one, these values are having maximum length. Maximum length is 40. Padding I'm going to have the padding as a post here. Run this one. Let's try to see how I have prepared the data before passing this one into the convolution neural network. Run this print of x. Okay, so the data will look like this. Okay, so that means we are having in the array format. So individual value I can pass to one input terminal using convolution neural network. Next is, let's try to check the shape here. So as for the shape of x data is concerned, I have 76 same record. There is no difference in record, but I have 40 features. Okay, hello.
Yes, sir.
Hello, 40 features I have. That means we need 40 input terminal to pass this one into convolution.
Sir,
Yes, sir.
sir,
Yes,
here
sir.
maximum
CLF
length is
next
for
before pass. Yeah.
sir, here maximum length is for number of
Maximum
words,
length
sir. For length of the word, sir.
exactly. Number of
Okay.
is length of the words. Maximum length of the words is 40. Suppose let us say you are passing one statement.
Yes, sir.
Okay, maybe that statement is having 32 or 34 words to say. So
Yes,
by
sir.
default maximum I'm going to set 40.
Okay. If a
Okay,
word
as
is
input terminal.
yes, sir. If a word is beyond that, then that will be truncated, sir.
It will be truncated, but it is not possible because we have the maximum length how much there in
Okay.
between 30 to 35.
Okay. Okay.
Okay, okay,
Okay.
so that's the reason 40 I have set. Next is CLF. Let me try to run this linear SVC first. Let's see whether how much accuracy we are getting after converting the data in other format. Okay, so here also 81 it's showing. There is no much difference. Okay, let's try to split this data in X and Y training data and testing data using the same code. Okay, so split test data concept generating here. I'm going to have 20% for my testing data. Now next it's time for CNN, convolution neural network. So vector size 100 I have set here. Okay, so that is for the character sequential model I'm going to use here. Sequentially I'm going to execute now. Add embedding, vocabulary size, embedding for the conversion of the data here, vocabulary size, vector size, input length size is nothing but the maximum length is nothing but the 40 here. Okay, so now next is convolution neural network, ID. 32 layers I'm going to have here. Okay,
Yes, sir.
input layer. Okay, 32 and two times. Okay, I'm going to execute this. That means I'm going to perform two times match pooling system. Clear?
Yes, sir.
Okay, so that means let's say here there is no concept of 24 into
Yes, sir.
24
Yes, sir.
pixel. So I'm going to use two hidden layers. Okay, so next my activation function is what here? Reload. Fine.
Yes, sir.
Okay, so just try to understand this concept.
Yes, sir.
Next, I'm performing match pooling again two times. Okay, now next I'm going to drop 50% of the layers. Batch size, let's say 32 batch size I'm going to have. I'm going to drop my 50% of the layer so using 0.5. Next dense layer 32 again, batch size is 32. Again, I'm going to have activation function as a reload. Okay, I'm dropping again 50% of the layer. Next, see, have a look on this 32 pix. I'm going to set 30 to 32 only for in the first two execution. Next is
Okay.
drastically I'm reducing it to 16.
Yes, sir.
Okay, 16 activation function again it is a reload. Next, this is for back propagation system. Okay, so that is the reason for back propagation I'm going to use global max pooling convolution neural network. Okay, so I'm going to have only one dense layer here, and again in the back propagation I'm going to use segment function, not reload function. Okay, segment function I'm going to. That means I'm going to set the range 0 to 1. Let's say you have set the range 0 to 1 and you have set the segment function, let's say 0.1. So we are going to have 9 cycles for the back in the back propagation system. But in the case of forward pass or the forward propagation, I'm going to have reload function. Let's say you have set the reload function as 0.01. So to reach 0 to 1, okay, we are going to have n number of execution in the forward pass. Let me try to run this. Okay, run this convolution neural network. You can set this one. You can perform normalization also. Suppose let us say you are not, if you are not getting the proper accuracy, you can go for normalization and hyper tuning parameters also. It got executed. Now it's time for the compilation. For in the compilation, so I'm going to have Adam function. This is one more kind of one more unit generally we use, okay, during the compilation time. Okay, binary classification, binary entropy. Obviously I have target function in terms of 0 and 1, so we use binary classification. I'm calculating the accuracy. Matrix should be here, the accuracy. Let's try to run this one, compile this. Okay, so it got compiled. Let's try to check whether it is my convolution neural network fits for my data or not. Okay, let's try to fit the data with the network CNN network by passing X train and Y train value. Okay, I'm going to set the epochs as 6. Epochs is 6. It's going to take. Let's see. Let's try to run the 6 epochs. 6 time I'm going to execute the same data. Validation data X test. I'm going to validate the model using test data. That is nothing but X test data and Y test data. Run this one. Okay, run this. Let's see. This takes little time, because I have 6 epochs. Have a look on this. How much accuracy we are getting in the first term? Can you see participants? Hello.
It is
In first epoch,
0.57.
no.
0.57.
Okay, let's see. Have a look at value. Accuracy value is this one.
Okay.
66.91 I'm getting. Okay, so in the second epoch, I got 79, right?
Yes, sir.
Third epoch, I got 84. That is better than TF-ID function, right?
Yes, sir.
79 I got here. So that means it's lesser than what I can say, uh, the TF-ID function. Here 77 I got. Again, that means it got reduced. Let's try to have 76 in the next epoch I got. 76 only we are getting. Have a look on this. Maximum how much we got? Hello? Hello?
Point 7, maximum 79, sir.
79 we got, but the loss is 45%. That means I'm going to drop some of the layers here. Let's try to increase this epochs and let's see whether I'm going to get better accuracy or not. Let's try to have 10 epochs. Okay, so how much you increase the epochs, no? So the chances of increasing the accuracy are also more. 90 accuracy 98 showing. Let's see. 191 we have. 191 epochs. 76 I got. See in the second train I got 76. 75. It has reduced. Let's see. Loss is around 72. 76. It increased. Got increase. 99.57. 99. That means 99 accuracy. It's very difficult. Maybe the model is overfitting here. Now, see how we look. 74 we got. 74 accuracy. Maximum how much here? Maximum is 76, no?
Yes, sir.
Hello.
Yes, sir.
76. Will you recommend this CNN for Berthel Varga? Sorry. Will you recommend CNN for sentiment analysis? Will you recommend participants? See, have a look. Maximum 76 coming in. But TF-ID is better, right?
Yes, sir.
TF-ID is better compared to CNN. That means CNN, I don't think so that it's better for, especially this data for this data set. CNN, I don't recommend CNS. Okay, CNN for sentiment analysis. Let's try to test this one. Okay, how output I'm getting. So I'm going to have one function called get encoded. Get encoded. I'm going to have X value. Okay, so X you just clean out with the previous values. So I'm going to use this one. Okay, to fit the data. Pad sequence X value you give. Maximum length is 40. Padding post you give. Just try to run this function. Okay, and I'm going to pass the X value. Now let's try to pass the X value, and then you call this function get encoded. X value, let us say I am thrilled to see this. Okay, so this is, let's say I have tweet. Okay, Twitter I have tweeted like this. I'm thrilled to see this one. I want to predict now. Okay, so whether it gives me 0 or 1. Okay, vector data. Vector is having my exact data here. Okay, run this one. Run this one. Vec is not, X is not defined. X is not defined. Run this one again. X is defined.
Sir, I think it is capital X, sir. Here you have used small x.
No. Function I'm using.
Same only. Okay.
Function I'm using, right? In function parameter I'm going to pass this parameter. Okay, so it got executed. Vec got encoded function you pass with the parameter. Let's try to see what answer I'm going to get. Have a look on this. So this is in the array format. First we need to convert this one into that the binary form. This one target for binary format 0 or 1. So to do that one, so I'm going to use this argument max model predict vec. Call this one predicted value is having. So that means here from here I'm going to pass my test value. Okay, so let's try to run this one and let's see what value I'm going to get for this vec. Now vec is having this value. That is, I'm thrilled to see this. Okay, let's try to run this. Can you see this? Array of 0. 0 means what? 0 means people are just talking about the disaster, right?
Yes, sir.
Hello. It has predicted correctly. That means I'm not talking about the disaster here, right? Yes or no? Hello. Hope you are understanding. I'm thrilled to see this. Okay, so this is not kind of an what negative word, right? It has predicted. That means it has given 0. 0 means it is not an people. This statement is not talking about the disaster, right? Hello. Hello. Any doubt? Any doubt?
Sir,
Hello.
sir, last line can you explain, sir?
Which one?
np.argmax. What np.argmax?
See here, what is happening? Okay, so you are going to get the values in this format. This is the 10 is the code for, okay, this I. Okay,
Yes, sir.
175 is the code for I am. Okay, 7 is the code for thrill. Okay, like this we have given here. Understood? So these are the rest of the array functions. Array what we have used here. Okay.
Yes, sir. Okay.
Fine. So that means it is not going to fetch this one. Only this code it is going to fetch. But now we have to convert this in with respect to my target data. As far as target data is concerned, what target data what we have? Only two values we have, right? Which are
Yes,
those?
sir. 0 and 1.
0 and 1. That means I need to convert that one. Okay, in terms of zeros and 1. To convert zeros and 1s, so I'm using this argument max value.
Yes, sir.
Okay, and it is in numpy. Okay, so numpy library and model predict. Okay, so I'm going to call model is having the predefined model. Okay, using the convolution neural network. Okay, vec is having my this function, which is this one, right?
Yes, sir.
Yes or no? Okay. And okay, axis I'm going to set as in -1 way. Now let's try to predict. The moment it got predicted, it's showing like 0. 0 is nothing but what? People are just talking about the disaster. This statement is talking about not. This statement is not talking about the disaster.
Okay, sir.
Hope you are clear.
Yes, sir.
Yes, sir.
Okay. Similarly, let's have the next one. Met with car accident. This is related to disaster, no?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Let's try to run this one, and let's see what model is going to predict. It should predict 1. I have executed. Okay, now the data is in Y. Vector encode Y, pass the value of Y. Okay, so next is, okay, so run this one. Let's see how the model is going to predict. 0. Can you see this?
Yes, sir.
Yes, sir. Yes, sir.
That means model is not predicting. Model is not predicting my Y value.
Yes.
Hope you are clear.
Yes, sir.
Okay, so that means I cannot depend on, I cannot rely on CNN. I cannot deploy this one in operational level. Next,
Okay.
let's have the BERT model. This is one of the beautiful model, one of the best model I can say. Okay, to run or handle sentiment analysis. This was designed by the Google in October 2019. They launched this one. Okay, and this model was used in many hackathon also. Okay, for the sentiment analysis, the purpose. The whole model divided in 2 parts. One is called supervised learning system. Okay, so after processing the data in supervised learning system, then it will be given to the unsupervised the learning system. Next is the what makes this birth model different from other. You take LSTM model is there because birth model is having the capacity to analyze in left to right as well as right to left.
Yes, sir.
Okay, means say how we read English from left to right. Okay,
Yes.
you take Arabic or Urdu, you take we read right to left. But if you take the other models, like LSTM model, you take any other model you take, either it will read from left to right, okay, or right to left. Birth is having both the option called right to left as well as uh,
Left to
left to right. Suppose if I want to analyze this, let's say met with car accident. So I can read from left to right. It is also possible to read from right to left. Left it means accident car with met. It is possible using birth algorithm. Okay, just try to do certain kind of an R&D here. Okay, how exactly the birth algorithm works, and maybe if you are planning your career in machine learning, you are widely, especially in sentiment analysis (NLP), you are going to use this birth model. Okay, so as far as birth model is concerned, we need one the library called K-Train. Okay, so K-Train is a wrapper library which comes with Keras and TensorFlow. Sorry, which comes with TensorFlow and Keras. Understood? Let me run this one. Pip install K-Train. K-Train. This takes a little time. Okay, it got executed. Okay, it got executed. I request you okay to learn this. Birth stand for bidirectional, encoded. Uh, R stand for yeah, representation from transformation. Okay, hold on. It is executing. So K-Train library we required. Okay, so after downloading K-Train library, yeah, successfully installed now. Okay, tweet head. Let's try to see the Twitter head now. Okay, so again, I'm going to work on my data. Tweet head. Tweet head. Okay, so data look like this. So I have vector format now. Target I have, text I have. Okay, so let me load this. Let me call this K-Train for text processing. Okay, and import this library. Import the library. Okay, it got input. Now, okay, so data is in. See, data already have split it, right? in X train and Y train format. Right, participants?
Yes, sir.
Hello.
Yes, sir. Sir,
Okay, so
sir,
this is, yeah,
sir, after namaz I will join,
yes.
sir. Okay, thank you, sir.
Sorry,
Sir, after namaz I will join,
sorry.
sir. Hello, sir.
Okay, fine, no problem. Okay, it's almost 5 minutes, Sania.
Sir, I didn't
Fine, fine.
Nuhur
Okay,
namaz.
fine, fine, fine. Carry on.
Okay, thank
Okay, fine, carry on. So, Swati ma'am, just 5 minutes, huh?
Yes, sir.
Okay, so here what I am doing, X train, Y train. I'm separating the data now. X train and Y train.
Yes, sir.
X test and Y test. Okay, it's for
Yes.
supervised learning and supervised learning system. Okay,
Yes.
so now pre-proc, I'm going to use one more library here. Okay, sorry, the variable called pre-proc. Okay, and this is the format of passing the value in birth algorithm. Okay, so text from df. Okay, data frame. Okay, so this method you call, okay, data frame, train data frame called twit. Twit is nothing but my exact data where the data is stored.
Yes, sir.
Text column is nothing but the text. That is nothing but the feature here.
Yes.
Okay, label columns is nothing but the target value. Okay, that is zeros and ones. Maximum length is 40.
Okay,
Okay,
sir.
and I'm going to process this one using pre-process model but.
Yes, sir.
Okay, so it's
Yes, sir.
pretty straightforward here. Okay, so only thing is this is the standard generally format we use to run the birth algorithm. Now next is run this one. Okay, so I think, yeah, hold on. Yeah, but it is downloading the pre-trained model.
Yes, sir.
Okay, so it got executed. Now my data, extract data is ordered. Now next I'm going to create one variable called model. Okay, so classifier, text classifier, name of the model is birth, training data. Okay, pass the training data, and pre-processing training data you keep as it is. Same thing what I have stored in the previous line here. Okay, so I have stored the pre-processing data in this one. So pass the same
Yes,
pre-proc. Okay, create this model, run this one.
yes, sir.
Okay, run this one. Maximum length is 40. Okay, so it got executed. Now next I'm creating one learner variable. Okay, call this get learner. Okay, so get learner method. Model name is model. Okay, where I have the birth algorithm. Okay, training data. Pass the training data using this variable. Sorry, method called train data, X train and Y train. Validation data is nothing but my testing data. Okay, that is nothing but Y of test data and Y of, sorry, X of test data and Y of test data. Batches, I'm going to create the batches of 64 here. In convolution neural network, we had 32, right?
Yes, sir.
Okay, here we are going to have 64 batches. Run this one, run this one, and the learning rate. The one of the challenging tasks here is to decide the learning rate. Okay, so learning rate itself will divide the decide the accuracy of the birth algorithm. Okay,
Yes, sir.
so here learning rate, what I have done, I have given the 2 to the power of e to the power of minus 5. Okay,
Oh, yes, sir.
e to the power of minus 5. Okay, so that means it is going to have 0.00001, I guess, the learning rate. And I'm going to have 3 epochs. Okay, 3 times I'm going to execute
Yes, sir.
using this method called fit to one cycle. Okay, if you
Sir, what
run
is
this one, okay, yeah,
sir? LR
hello,
means what, sir? LR. What
learning,
does
learning, learning, learning rate.
means? What will do, sir?
Learning rate means it tried to decide small, it tried to take some threshold value. Okay, like
Okay.
relo function and segment function in convolution neural network. Okay, in convolution neural network, what happened? We try to set the learning rate as 0.01 in segment function, and in relo function we are going to have 0.01.
Okay, sir.
What is the difference now? If you are setting as 0.1, we are going to have 9 cycles.
Okay.
Okay, 9 cycle to reach from 0 to 1. If you are setting the learning rate as, let's say, 0.01, to reach from 0 to 1, how many cycles are required?
9.
I think
10.
19, no. To reach from 0 to
Okay,
0.
okay, sir. Okay,
To reach
okay.
from 0 to 0.1, we need 10 cycles. And to
Yes,
reach from 0 to 1, we require 100 cycles.
okay.
Clear?
Yes, sir.
In
Yes,
the
sir. Yes,
same way, here also we are setting the learning rate. Learning rate, that is 2 to the power of 2 into e to the power of minus 5.
sir. Okay,
So
sir.
that means we are going to have the learning rate as 0.00001, I guess.
Okay, sir.
And I'm going to set the epochs as 3 here. That means 3 times I'm going to
Okay.
execute.
Yes, sir.
But the challenging task is, okay, so to decide the learning rate itself is a challenging task in the birth algorithm.
Okay, sir.
Okay, so what I have done, I have set the learning rate as 2 to the power of 2 into e to the power of minus 5. So you
Yes,
can, if you are having the, if the moment when you are practicing this algorithm, you try for 2 to the power of 2 into e to the power of minus 4 also.
okay, sir.
Okay, because it's going to take a lot of time, 3 hours it takes minimum. Okay,
Okay, sir.
the moment when you run this one. Okay, and there is one more, the code. Through that you can find out the learning rate also. How much is to decide by running this code. Learner.lr underscore find.
Okay.
Okay, or
Yes,
learner dot, okay, similarly by side if you want the visualization you can this lr underscore plot.
yes, sir.
Okay, but it takes lot of time, hours, many hours it takes, or sometimes it takes days also. Okay, so that's the reason I don't want to run this, the code. Later on you can try if the system, if you have a lot of time you can run this code also. The
Yes,
next is to predict once the model is ready. Okay, and that model is going to store in learner. Okay,
yes, sir.
hello,
Yes, sir.
model is I'm going to store in the learner dot model. So create one observation, I mean the variable called predictor,
Yes, sir.
call ktrain get predictor. Okay, here get learner get predictor, learner dot model. Okay, and pre-proc you forward this one. Now next after that create the data. Create the data. Let's say the people are tweeting like this. I met you today by accident. Okay, let's say the next data is I got today car accident. I am injured.
Yes, sir.
Understood. So this is my data. Next, what I'm going to do by using that model called predictor dot predict.
Yes, sir.
Okay, so I'm going to run this data. Okay, using, okay, probability. Let's say return probability is 2. So here, okay, so the complete the data I'm going to have in 1 and 0. Okay, so you can run this one later once after executing this data. Fine. You will have the list of in this. It try to give the list of the data which fall under the disaster. I met you today by accident. This is not about disaster, no.
Yes, sir.
That means this is falling under the category of 0.
Yes, sir.
And I got today car accident. This fall under the category of 1.
1.
I am injured, fall under the category of 1. That means this will be having these two values, these two data.
Yes, sir.
Okay, and this will have this data. Fine.
Yes, sir.
Okay, so let's try to run this one. Let's try to run my model. Okay, so run this one. Okay, and it's taking time. So it's take around 3 hours. So I'll try to share this file.
Yes,
You
sir.
can try in your system also. Fine.
Okay. Yes, sir.
Okay, so let me share this one. You just try this one in your system. Fine.
Okay, sir.
This takes around 3 hours. Trust me.
Okay, sir.
Share. Let me share.
Okay, sir.
One second. Do you have data set?
No, sir.
Data set is there?
No, sir. No, sir.
Okay, fine. I'll share the data set.